Hello everyone, I hope you're all having a good day. Alright, so in the previous videos we talked about list comprehension. Now we're going to be talking about generator functions. So you should be familiar with what a function is. It's basically you have the option to take in parameters and you have the option to return something. So in a regular function, whenever you return a value, that's when the function ends. So any line of code after that return statement does not get executed. So a generator function, however, is a bit different in that it does share the same syntax. You are basically defining a function, but a generator function allows you to create functions that kind of behave like iterators, basically meaning you can iterate through the function. So basically you can use this in a for loop. So if if you were to iterate through a list, you might say for element list or for element string, right? That's how you would iterate through both or list or string or any iterable collection. So with a generator function, we can replicate this behavior and we can just print element. So let's run our code. Oops. Let me get rid of this. Okay, so let's run our code one more time. And you get 5, 10, Python 100. So let's take a look at our generator function. So over here we have a regular function. If I make a function call, it will always return 5. Oops, come on. Yeah, so 5, and this 10 will not return, right? Because it's just it's a regular function. You have one return one return value. And so in a generator function, instead of having the return keyword, we have a yield keyword. So basically, every time you yield a value, that's one iteration. So here we have yield 5 for the first iteration. So element is 5, then yield 10, then yield Python, the string. So that's our third iteration. And then our last iteration, our fourth one, is 100. Run it again. So you see 5, 10, Python 100. So let's get rid of this. So why is this useful? Well, you can, because this is a for loop, you can simply just put this in a list bracket, right? And this will be a list comprehension. So if I assign this to list, save this and print our list. Why is there an error here? For element, let's just run it and see what happens. Oops, silly me. Element for element gen func. We can do 5, 10, Python 100. And actually, with a generator function, you don't even need the list comprehension syntax. You can just say, you can just use the list constructor. So you can just do list and pass in the function, and then let's save, and it will generate these values for you. So with a generator function, you don't really want to have a whole list of yield statements. Instead, you should probably use a while loop or a for loop. So let's look at the next example, and we have our 2's powers. So basically, this sequence would generate the powers of 2's starting at 1. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 3 is 8. No, did I skip something? 2 to the 2 is 4, and then 2 to the 3 is 8. All right, so we were to do for element in 2's power and just put in 1. Let's save and run it. We get 1, 2. So it's from 2 to the 0 and then 2 to the 1, but including that 2 to the 1. So how do we write this? We kept a total, and then we have our while loop. So while n is greater than or equal to 0, you just yield the value. So it's kind of like, in this case, we're yielding 4 times. In this while loop, we're yielding n times. So whatever n is, or n plus 1. So if we put in 1, this yield gets called twice because the while loop repeats twice. And then we double our total for the next iteration, and then we subtract 1 from n so that we're not stuck in an infinite while loop. Okay, so if I make this 7, we should get up to 128, right? So 1 to 4 is, you gotta scroll very carefully. 1 to 4, 8, 16, 32, 64, and 128. Okay, so that's how you would use a generator function to create some type of sequence or just to iterate through a list. So speaking of iterating through a list, why is it that we can write this syntax for elem in list? Because this is actually a generator syntax, right? Normally, you would do for I in range length of the list, then you print list index I. Well, that's exactly what's happening. Inside the list class, we have a method. It's an operator actually, which looks something like this. Don't worry about this for now, because in a later video we're going to be implementing the list class ourselves from scratch, and you'll see how this iter works. So for now, I'm just going to use a function. So I'm just gonna name it iter list, and it takes in a list object. So basically, in the list class, what's happening is you have an array, right? Remember, every list has an array, and every array we have these indices. So we're just iterating through from the indices from 0 to the length of the list, and we're yielding the value at I. So if I have a list of, let's say, 10, 12, 40 Python, I can do for elem in iter list and pass in my list and just print elem. So let's see what that looks like. And you get 10, 12, 40 Python. So this is actually how it works in the built-in list class. Again, because this is not a method, if we use the underscore iter that I mentioned before, which I will show you in later videos, we wouldn't actually have to call the function. Since it's an operator, we would just say for element list. And so that's how it works. Okay, so let me backtrack. All right, so that's how for element list works. And then what about the range, right? Is this a generator function? Because we can do for I in range, and we have like start, stop, and step. So this is from 1 to 10. So let's run this, and we get 1 to 9 because we stop at 10, right? So is this a generator function? Actually, it's not a generator function, but we can create something similar to it using generator function. So let's comment this out. So how will we do it? We would just, let's name it my range, and we'll have a start, stop, and a step. So we have 3 parameters on our function. And then basically it's actually very simple. While start is less than stop, so while the start value has not passed stop, we can yield start. And then we will bump start up by the number of steps. So if I take the previous for loop statement and just change it to my range 1, 10, 1 and print I, we should see the exact same behavior. So let me clear this and then run it again. We get 1 to 9. And if we decide to go by steps of 2, we get the odd numbers, right? So 1, 3, 5, 7, 9. Okay, so this is how you can use generator functions to create something that you can iterate through. So this could be a sequence. Yeah, so that's basically it. In future videos, we'll be using generator functions more. And yeah, so it's good that you understand how the generator function works and what it is. All right. So yeah, that's that, and hope you have a good one. Bye bye.